Once again, welcome back to the video series on Math Revision Made Meticulous, Day 19, Properties of Definite Integral. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us move on to the next property of definite integral. If f of x is a continuous function defined on closed interval 0 to a, then integral 0 to a f of x dx is integral 0 to a f of a minus x dx. Here what we have to observe is lower limit is 0, upper limit is any real number, and the limits are not changed in the property, only f of x is changed as f of a minus x. Suppose if it is 0 to 1, x should be replaced by 1 minus x. If it is 0 to pi by 2, x should be replaced by pi by 2 minus x. If 0 to pi, x should be replaced by pi minus x. Once again, please observe the property, lower limit 0, upper limit any real number. Limits are not changed in the property, only f of x is changed to f of a minus x. Let us move on to some questions now. Integral 0 to 1 x into 1 minus x whole power n. If you apply the property, the integrand will get automatically changed into a new integrand, where you will be able to integrate it directly in some case. Otherwise, we will see what we have to do. Here, I am replacing x by 1 minus x because a is equal to 1. Therefore, 1 minus x, 1 minus of 1 minus x. When I expand the bracket, 1 and 1 will get cancelled. I will get 1 minus x into x power n. It is a normal brackets to be expanded. X power n minus x power n plus 1. X power n integration is x power n plus 1 by n plus 1. X power n plus 1 integration is x power n plus 2 by n plus 2. When I apply the upper limit as 1, it is 1 upon n plus 1 minus 1 upon n plus 2. When I apply the lower limit, it is 0. Final answer 1 by n plus 1 minus 1 upon n plus 2. Here when you apply the property, you are getting the integrand which can be integrated directly. Now suppose if it is not possible, when you apply this property you are getting a integral which is little bit modified, then replace x by x minus a, simplify and get the new integrand, then express the given integrand is equal to half into integral 0 to a sum of the two integrand. The integrand which is given in the question and the integrand which you got by replacing x by x minus a. Here remember, some book will call it as 2 into the integral also. I have used 1 by 2 so that you will not forget that 2. Then simplify and integrate. We move on to question number 2. Integral 0 to pi by 2 log tan x dx. The lower limit is 0. I continue. Integral 0 to pi by 2 log tan x dx. I replace x by pi by 2 minus x. Tan pi by 2 minus x is cot x. Therefore, it becomes log of cot x dx. I started with one integrand. I got another integrand. For I have to write each integrand is equal to half into sum of the two integrands. For log tan x plus log cot x. Let us check out whether it gets simplified. Log tan x into plus log cot x is log tan into cot. Tan and cot are reciprocal to each other. Therefore, log 1. What is the value of log 1? It is 0. Therefore, final answer is 0. Here what we have done? We started with one integrand. By applying the property that integral 0 to a f of x is integral 0 to f of a minus x, we got one more new integrand. Write each integrand, that is a given integrand, is equal to half into sum of the two. You can also write 2 into the integrand also, but don't forget to divide the right hand side by 2 after your calculation is over. Let us move on to question number 3. Here integral 0 to a x by x plus root a square minus x square. All of you may be tempted to check out, sir, shall I replace x by a minus x and all. But when you do substitution, because you are seeing a square minus x square in the denominator, put x is equal to a sin theta, dx will be a cos theta d theta, theta will be sin inverse x by a. Now we have to change the limits. When I have x is equal to 0, theta will be sin inverse 0, therefore 0. When I have x is equal to a, theta will be sin inverse of a by a, which is 1, which is pi by 2. For I got a new integrand now, integral 0 to pi by 2 a sin theta by a sin theta plus root a square minus a square sin square. Now I will take a square outside inside the bracket square root. It will be a square into 1 minus sin square. I continue. What is 1 minus sin square? It is cos square. When you take the square root, it will become a sin theta by a sin theta plus a cos theta. Therefore, sin theta by sin theta plus cos theta. It is a very famous problem. integral 0 to pi by 2 sin theta by sin theta plus cos theta, integral 0 to pi by 2 by root sin theta by root sin theta plus root cos theta, integral 0 to pi by 2 by sin power 3 by 2 theta by sin power 3 by 2 theta plus cos power 3 by 2 theta. All this problem leads to the same answer pi by 4. Let us see. I take this problem now. Now I have the lower limit as 0, upper limit as pi by 2. Replace wherever theta comes as pi by 2 minus theta in f of x, that is f of theta. For sin pi by 2 minus theta is cos theta, all of you know. Therefore, it will become cos theta by cos theta plus sin theta. But when you add the integrand now, half into integral 0 to pi by 2, first integrand is sin theta by sin plus cos, second is cos by cos plus sin. When you take LCM, then you will sin theta plus cos theta will get cancelled. Therefore, you will get only integral 0 to pi by 2 d theta. That integration is theta from 0 to pi by 2. When I put pi by 2, upper limit minus lower limit, I get the answer as pi by 4. Very simple. We did a substitution. After that, the integrand got reduced to integral 0 to pi by 2 sin theta by sin plus cos. I used the property. It get reduced to integral 0 to pi by 2 d theta only. Let us move on to question number 4, where integral 0 to pi x sin x by 1 plus cos square. We will apply the same property because we are observing here lower limit is 0, upper limit is pi. Replace wherever x comes as pi minus x, for pi minus x into sin of pi minus x by 1 plus cos square pi minus x. Now we have to identify what is sin pi minus x. It is sin x. Cos pi minus x, it is minus cos x. But there is a square there. Therefore, it will become pi minus x into sin x by 1 plus cos square x only. No change in the sign. Now we started with x sin x by 1 plus cos square. We ended with pi minus x by 1 plus cos square into sin x. Therefore, now write it as half into sum of the two integrands. That is x sin x by 1 plus cos square plus pi minus x into sin x by 1 plus cos square. Now x sin x, x sin x when you add will get cancelled. Therefore, you will get pi sin x by 1 plus cos square. For half into integral 0 to pi sin x by 1 plus cos square. Now let us continue now. Pi I am taking it outside. Now I am seeing that the numerator contains a differentiation of cos x. Therefore, I am putting u is equal to cos x and du as minus sin x dx and du as minus du as sin x dx. For when x is equal to 0, the new variable, that is u is equal to cos 0, which is 1. When x is equal to pi, the u will be cos pi, which is equal to minus 1. Therefore, the lower limit is 1, the upper limit is minus 1. Therefore, half into integral 0 to pi sin x by 1 plus cos square dx will be pi by 2. The lower limit is minus 1. So, lower limit is 1, upper limit is minus 1. Therefore, 1 to minus 1. Sin x dx is nothing but minus du. 1 plus cos square x is nothing but 1 plus u square. What is the formula for it? It is tan inverse u from 1 to minus 1. Apply the upper limit now. Tan inverse of minus 1 minus tan inverse of 1. What is tan inverse of minus 1? It is minus pi by 4. Tan inverse of 1 is pi by 4. For minus pi by 4 will be minus pi by 2. Already you are having a minus pi by 2 in the outside. For final answer is pi square upon 4. Here what we have done? We have taken the problem. We did apply the property of integral a to 0 to a f of x dx is integral 0 to a f of a minus x dx. It got reduced to a integral where we can do it by means of substitution. Here once again it is a problem of substitution where limits are there. Where we have changed the limits, then directly we have applied the limit. We are moving to the next property, which is actually the same property as we have done. Suppose if it is a to b f of x dx can be written as a to b into f of a plus b minus x into dx. In the last property we had 0 to a. Therefore 0 plus a is a only. Therefore you had a minus x there. Both are actually this that property 0 to a may be considered as a special type of this property only. But sometimes what will happen when you replace f of x by f of a plus b by a minus x, the integrand will get reduced. Let us see one question now. The limits are not changed, only f of x is changed to f of a plus b minus x. Be careful, lower limit is not 0, upper limit is is a real number. Both lower limit and upper limit are real numbers. Let us go to this problem now. 1 to 2 root x upon root 3 minus x plus root x. Here normally when you see the problem you will be tempted to do this problem by means of multiplying and divide or rationalizing, whatever you call. But that may be little bit lengthy. Therefore, let us now try to apply the which property we have seen. What is a plus b? A plus b is 3. Therefore, I am replacing wherever x comes as 3 minus x, because a plus b is 3 here, but I am replacing it by 3 minus x everywhere. For it will become, I am not changing the limit, okay. 1 to 2, numerator will become root 3 minus x, denominator will become root x plus root 3 minus x. Now the last property which already we have done, we started with the integrand, we got another integrand. Each integral will be equal to half of sum of the two. Therefore first integrand is root x by root 3 minus x plus root x. Second integrand is root 3 minus x upon root x plus root 3 minus x. The denominators are same, add the numerators. Therefore numerator and denominator will get cancelled. You will get only 1 by 2 from 1 to 2 of dx only. Therefore it is x is the integral value of this integral dx from 1 to 2. Therefore 2 minus 1, the answer is 1. Very simple. Here we have started, even though the lower limit is not 0, we are using another property. Integral a to b f of x dx is integral a to b, no change in the limit, upper limit and lower limit, f of a plus b minus x. Replace x by a plus b minus x. Here a plus b is 3. I have replaced it by 3 minus x. Success is dependent on efforts. All the best. Thank you.